You are tuned to Iri-e-learning and I am your host, Teacher. In this lesson on mole concept, we will practice calculating the molar mass and relative mass for elements and compounds. Check the description box for links to all the videos related to this unit. By the end of this lesson, we should be able to calculate molar mass and relative mass. That is, whether relative molecular mass or relative formula mass. Example 1. Calculate the molar mass and relative mass for the compound calcium chloride. If you don't know the chemical formula for calcium chloride offhand, don't worry. We can derive it. You can also review the Unit 5 lesson on writing chemical formulae for more details. We begin with recording the chemical symbols of the atoms present in calcium chloride. That is Ca for calcium and Cl for chlorine. Calcium has a stability number of 2 because it's in group 2 and will lose 2 valence electrons to become stable. Chlorine has a stability number of 1 because it's in group 7. Therefore, chlorine accepts 1 electron to complete the 8 electrons on the valence shell to become stable. Since a common factor greater than 1 does not exist between the stability numbers, they are crossed over to the right base of the adjacent atoms. So 1 goes to the base of calcium and 2 goes to the base of chlorine. We do not write the numeral 1 in a chemical formula, so that disappears, and the chemical formula for calcium chloride is CaCl2. Now that we have the chemical formula for calcium chloride, we will begin with calculating the molar mass and then follow through with the calculation for the relative mass. So step 1, we will record the symbol and quantity of each atom present in the compound. There is 1 calcium atom, 1 Ca, and 2 chlorine atoms, 2 Cl. Step 2, record the mass of 1 mole of each atom in the compound. As we can see from our periodic table information, the mass of 1 mole of calcium is 40 grams and that of chlorine is 35.5 grams. Step 3, multiply the mass of the atom by its quantity and record the product. So for calcium, it's 40 grams times 1 calcium atom, which equals the product of 40 grams. Chlorine is 35.5 grams times 2 chlorine atoms to give 71 grams as the product. Step 4, we will find the sum of the products. So we're going to add 40 grams to 71 grams, and that gives us 111 grams. Note that we used the mass of 1 mole of each element in the compound, so therefore we have actually found the mass of 1 mole of calcium chloride to be 111 grams. Recall that the mass of 1 mole of a substance is the molar mass. Therefore, the molar mass of calcium chloride equals 111 grams per mole. So we are finished with calculating the molar mass for calcium chloride. Now we will move to finding the relative mass for calcium chloride. When calculating the relative mass, we use the same procedure as the one we just used for finding the mass of 1 mole of the substance. The only difference is the mass of 1 mole of calcium chloride, which is 111 grams, is compared to 1/12 of the mass of carbon 12. If you recall from our previous lesson, it causes the loss of the unit grams. As a result, the relative formula mass for the ionic compound calcium chloride equals 111. So recall that the term relative indicates that the mass would have no units. Example 2. Calculate the molar mass and relative mass for the compound carbon dioxide. Let us derive the chemical formula for carbon dioxide. Also, you should review the Unit 5 lesson on writing chemical formulae for more details. We record the chemical symbols of the atoms in carbon dioxide, that is C for carbon and O for oxygen. Carbon has a stability number of 4 because it is in group 4 and needs 4 valence electrons to become stable. Oxygen has a stability number of 2 because it's in group 6. Therefore, oxygen needs 2 electrons to complete the 8 electrons on the valence shell to become stable. Note that there is a common factor of 2 between the 2 stability numbers, so we divide through by that common factor of 2. Therefore, 4 divided by 2 gives us 2, and 2 divided by 2 gives us 1. We then cross over the values to the right base of the adjacent atoms. So 1 goes to the base of carbon and 2 to the base of oxygen. Recall, the numeral 1 is never written in a chemical formula. So the chemical formula for carbon dioxide is CO2. We will now calculate the mass of 1 mole of carbon dioxide, from which we will deduce the molar mass and relative mass. Step 1, record the symbol and quantity of each atom present in the compound. There is 1 carbon atom and 2 oxygen atoms. Step 2, record the mass of 1 mole of each atom in the compound. The periodic table information shows that the mass of 1 mole of carbon contains 12 grams and that of oxygen is 16 grams. Step 3, multiply the mass of the atom by its quantity and record the product. So for carbon, we have 12 grams multiplied by 1 carbon atom, giving a total product of 12 grams. Oxygen, 16 grams multiplied by 2 oxygen atoms to give a total product of 32 grams. Step 4, find the sum of the products. So 12 grams plus 32 grams gives a total of 44 grams. Since we used the mass of 1 mole of each atom in our calculation, we have actually calculated the mass of 1 mole of carbon dioxide to be 44 grams. Recall that the mass of 1 mole of any substance is the molar mass. Therefore, we can say the molar mass of carbon dioxide equals 44 grams per mole. So we have just found the molar mass for carbon dioxide, and we will now find the relative molecular mass for carbon dioxide. Remember, carbon dioxide is a covalent compound. And if you recall from our first example, we use the same 4 steps for finding the mass of 1 mole, from which we would deduce the relative mass. So in deriving the relative mass of carbon dioxide, we actually compare the mass of carbon dioxide to 1/12 of the mass of carbon-12. What happens is the denominator becomes 1 gram and the units cancel each other. So as a result, the relative molecular mass of carbon dioxide equals 44. Now, this step for deriving the relative mass is not required. After calculating the mass of 1 mole of the compound, we simply record the answer without units for the relative mass. So from this point, after finding the mass of 1 mole of carbon dioxide, we could have just simply have written the relative molecular mass of carbon dioxide is equal to 44. So we just write the value of the mass of 1 mole without the unit. Example 3. Calculate the molar mass and the relative mass for ammonium sulfate. Let us derive the chemical formula for ammonium sulfate. It contains 2 radicals, NH4, the ammonium radical, and SO4, the sulfate radical. The Unit 5 lesson on writing chemical formulae provided the stability numbers for a few common radicals, including the ammonium radical and the sulfate radical that we're using here. The radicals are placed in brackets before recording the stability numbers. The stability number for the ammonium radical is 1, and that of the sulfate radical is 2. The stability numbers have no common factor greater than 1 between them, so the values are crossed over to the right base of the adjacent atoms. 2 goes to the base of the ammonium radical and 1 to the base of the sulfate radical. The numeral 1 is never written in a chemical formula, so it's erased along with the brackets surrounding the radical. Consequently, the chemical formula for ammonium sulfate is open brackets NH4, close brackets 2, SO4. We can now find the molar and relative masses for ammonium sulfate. Step 1, record the symbol and quantity of each atom present in the compound. So we have 2 nitrogen atoms, 8 hydrogen atoms, 1 sulfur atom, and 4 oxygen atoms. Step 2, record the mass of 1 mole of each atom in the compound. The periodic table information shows us that the mass of 1 mole of nitrogen is 14 grams, that of hydrogen is 1 gram, sulfur 32 grams, and oxygen 16 grams. Step 3, multiply the mass of the atom by its quantity and record the product. So for nitrogen, we have 14 grams times 2, which gives a product of 28 grams. Hydrogen has 1 gram times 8 atoms of hydrogen to give a total of 8 grams. Sulfur has a mass of 32 grams times 1 sulfur atom, giving a total product of 32 grams. And finally, oxygen has a mass of 16 grams times 4 oxygen atoms, which gives a total product of 64 grams. Step 4, find the sum of the products. So when we add all the products together, we get a total of 132 grams. This mass, 132 grams, is the mass of 1 mole of ammonium sulfate, since we actually used the mass of 1 mole of each atom when we did the calculations. Consequently, the molar mass of ammonium sulfate is 132 grams per mole, and the relative mass equals 132. Remember, when we see the term relative, it means it has a value that carries no units. So for relative mass, it is the value, which is 132 in this case, but it has no units of grams. Here is the lesson summary point. The molar mass and relative mass of a substance are calculated using the same method of finding the total mass of 1 mole of the element or compound. It's quiz time. You have 5 seconds to answer each question after it is read aloud. Question 1. For which of these compounds could you find the relative formula mass? A. Sodium chloride, B. Oxygen, C. Carbon dioxide, D. Hydrogen chloride. The answer is A, sodium chloride. Note that sodium chloride is an ionic compound, and as a result, we find the relative formula mass for ionic compounds. Question 2. For which of these compounds could you determine its relative molecular mass? A, NaCl, B, CaO, C, MgO, D, CO2. The answer is D, CO2. We find the relative molecular mass for covalent compounds. Question 3. The element oxygen has an atomic mass of 16 grams. What is the molar mass of its diatom? A, 32, B, 32 grams per mole, C, 8, D, 8 grams per mole. The answer is B, 32 grams per mole. First of all, we are finding the molar mass, so we know it must have units of grams per mole. Since the atomic mass of oxygen is 16, the diatom, meaning it has 2 atoms of oxygen in the molecule, then that would be 16 plus 16, which gives a total of 32 grams per mole. Question 4. Use the data from the periodic table on the right to calculate the relative molecular mass of carbon dioxide. A, 22 grams per mole, B, 22, C, 44 grams per mole, D, 44. The answer is D, 44. We are finding the relative molecular mass, so the value should not have any units attached. And here we show how we have calculated the relative mass for carbon dioxide. Question 5. Use the data from the periodic table on the right to calculate the molar mass for the compound N2O2. A, 60 grams per mole, B, 60, C, 30 grams per mole, D, 30. The answer is A, 60 grams per mole. Recall that molar mass has units of grams per mole. Here is a display of how the calculation was done. We have reached the end of our lesson. If you found this video helpful, remember to like, share, and subscribe. When you subscribe, you will receive notifications as new videos are uploaded. So until next time, I am Teacher with Iri-e-learning.